The last little piece is a bit different. I'm asking you to do limits here, not derivatives. This is, well, first of all, we know a derivative is just a type of limit. But second of all, these have some applications later on. And so we need to make sure we know how to evaluate them now before we get to that point. So what we know, we're approaching 0. Can I just plug in 0 right now? No, because it would give me sine of 0 over 0. But remember, the limit as x approaches 0 of sine x over x equals what? 1. So this is what we've used in the past. Now, it can be extended, and it turns out as long as the argument of your trig function and the denominator are the same, this will still go to 1. So if I'm focusing on my trig function, this is a sine of 7x. So what would I have to have on my bottom?
7x.
7x. Okay, so here's what we're going to do. I'm going to multiply by 7 on top and bottom. I'm doing it on both because we know you can't just change the top. We can't have to be equivalent to the original problem. So on the bottom, I'm just going to write this as 4 times 7x. Or another way we could think about this. The 7 over 4, I don't really need that. I could pull those apart. So now, my argument, 7x, matches my denominator, 7x. So we can do this limit. So the 7/4 is just a coefficient. It stays. What's the limit as x approaches 0 of sine 7x over 7x? 1. And so this limit equals 7/4. So if we can get it to be sine of something over that same something, then we can evaluate it. Is that one okay? All right. So the limit as x approaches 0, tangent 3x over x. Can I just plug in my 0? No, because I get tangent of 0 divided by 0. And we can't do that. So, any thoughts on what we could do? Okay. We are going to do that, but not yet. We can't separate this angle. 3x, can't do anything about that. But what is tangent? What's another way I could write tangent?
Sine over cosine.
So this is like sine 3x over cosine 3x. Divided by x. So that's like an x over 1. So we could flip and multiply. Okay. So these things are multiplied, so I can kind of move them around a little bit. I'm going to put the x under my sine, and then 1 over cosine 3x out to the side. In order to evaluate this, sine 3x over x, what do we need? A 3 on the bottom. If I put a 3 on the bottom, though, we have to do it on the top. Would it be okay if I moved it and put it on top over here? Because these 3's would still cancel out, because they're multiplied together, 1 on top, 1 on the bottom would drop. So I haven't changed my problem. Now, if I evaluate this limit, sine 3x over 3x, what's that going to go to? Right, this is 3 over 3 times 0 is 0. What is the cosine of 0? 1. Oh, good. Let's look at another one then. So what are your thoughts here? Don't second guess yourself.
Okay, so just you want. Could
Huh?
you just separate it?
Yeah.
Yeah.
Sine squared means you have sine theta times sine theta. Theta squared is theta times theta, so I could separate it like this. Do you guys agree that if I multiply these fractions, I would get back to sine squared over theta squared? Alright, so sine theta over theta will go to 1 times sine theta over theta goes to 1. Now 1 times 1 is 1. Alright, so all we're doing is practicing how to manipulate these things. I can't just plug in because I get 0 over 0. So what can we do instead? We have sine 2z. What should I put underneath that one? Leave the z there. I don't want the cosine 3z, so I'm going to separate it out to the side and I'll just put a 1 on top. So what do I need to add into this problem? A 2. If I'm going to put it on the bottom, I also need it on the top. I'll just put it over here in the second fraction that has the stuff we don't need. So then, this, go to 1, times 2 is 2, over the cosine of 0 is 1. Thank you. Okay. Let's see how far you guys can get on the next one.
Sine 3 theta over theta, and then did it again.
I like that twang there.
My bad.
So this is sine 3 theta, sine 3 theta. So what did you put underneath?
Theta.
We have 2 thetas, so you can put a theta underneath, and we still have a
Cosine theta.
cosine theta there. All right. So this one needs a 3, so we have to put a 3 here. This one needs a 3, so I need another 3 up here.
Right. Yeah.
So this goes to 1 times 1 times 9 over 1. And we get 9. So far, so good? Just a few more. You guys try the next one again. All we need is a 2 on the bottom, so you have to put a 2 on top. This goes to 1 times 2, which is 2. Okay, let me ask you a question before we go to the next example. if I gave you the limit as theta approaches 0 of x over some, or sorry, I should say as x approaches 0, x over sine x. If I flip it, what would that equal? Maybe.
0, 1, 0.
Let's see. Okay. So, a reciprocal wouldn't this be the same as 1 over sine x over x? If I flip and multiply, it gives me back x over sine x. Do you guys agree with that? No? Okay, so if we were to work this out, it's 1 times, you would flip and multiply.
Yeah, why?
Huh?
What is sine of 0?
The limit x approaches what?
What is sine of 0?
0.
Oh.
Okay, but now look. When we have limits, we learned that we could do the limit at the top and the limit at the bottom, right? So the limit at the top is just a constant, so that doesn't change. What is the limit as x approaches 0 of sine x over x? 1. So this is still equal to 1. So it turns out the reciprocal is also equal to 1. So we could use that. If things are flipped, it's still going to work. It's still going to go to 1. So this one. We have to figure out what we're going to do with this. I'm going to go ahead and pull these apart. So we have a sine 2x on the top, and this one would have a sine 5x on the bottom. All right. In order to be able to evaluate this, what would this one have to have on the bottom? A 2x. Okay. But if I put a 2x on the bottom, I have to put it on the top somewhere. Would it be okay with you if I put the x here and I made another fraction where I put the 2? Because I don't want a 2x on this one. What do I want on that one?
5.
A 5x. So if I'm going to put a 5 on the top here, what else do I have to do? We have to put a 5 on the bottom. So the 2x's would cancel, the 5's would cancel, so we haven't changed our problem. With the limit x approaches 0 of sine 2x over 2x, that goes to 1. Times 5x over sine 5x, I just told you that also goes to 1. Times 2 over 5. So we get to this, right? See if you guys can do this. All right.
Bam.
So we have x, cotangent is cosine over sine. So we could just group the x over sine x together times the cosine x. So 0 over sine 0, what's that go to? 1 times the cosine of 0, which is 1. All right, so I am officially done with this section. We turned in day 1, didn't we?
Yeah.
So we have days 2 and 3 due Monday. You've got a lot of time today, and I'm planning for the full day tomorrow. I don't know if we'll need that much. But I wanted to make sure to give you plenty of time with everything else that's going on this week and weekend. I don't really want you to have a ton of homework. So, want you to work on that. Game plan next week. We will probably, we'll do a review day Monday and probably a quiz Tuesday over these trig functions before we move on, just to make sure we have those